Okay, look at the question number 3. Okay, this is tutorial chapter 5. Okay, for a load RMS 110 angle 85 and IRMS 0.4 angle 15. So the question is determine the complex and apparent powers. Okay, determine the complex and apparent power. So how to start? Okay, first of all you need to draw the equivalent circuit. Okay, so you need to draw, so you should imagine how's your circuit looks like. Macam mana bentuk circuit tu. Okay, saya buka whiteboard dulu. Whiteboard. Okay. Okay. So, macam mana for a load? Okay, saya lukis dulu kat sini ya. Saya lukis dulu kat sini. Nombor satu circuit. Okay, load. Kita ada load. Alright. Kita ada load. Let's say Z load lah. Let's say Z. So given VRMS across the load and IRMS, okay, flow to the load. This is a VRMS. Okay, this is our circuit. Okay, so the question number 1. Okay, determine the complex power. So basically, what is complex power? Okay, I try to explain slowly. Complex power actually is S. Apparent power actually is magnitude of complex power. That's why we call it apparent power. Okay, the magnitude of complex power. Okay, so right, so draw the circuit. Okay, we have a circuit. Okay, Z. Okay, so we have a, okay, please bear in mind we are given VRMS and IRMS. Okay, so in order to determine the complex power, number 1, the question asks you to determine the complex power S. Okay, so S equal to VRMS times by IRMS conjugate. Okay, conjugate. Okay, this is the fundamental. This is the fundamental. So what is V? Okay, VRMS. So the question okay, we have a VRMS, the info of VRMS. So we have a VRMS which is 110 angle 85 volt times by IRMS conjugate. Okay, please bear in mind. Okay, conjugate 0.4 angle, so positive become negative because of the conjugate. Okay, ampere.
Sir,
Yeah.
kalau degree dia dah negatif, tak negatif dia.
Tak. Dia apa ni? Conjugate ni masih berlawanan. Kalau let's say okay, let's say mungkin soalan kamu, let's say IRMS is 0.4 angle minus 15. So when we conjugate that IRMS, so we have a positive 15 lah. Boleh?
Oh, kena conjugate untuk IRMS.
Ya. Sebab equation dia adalah conjugate IRMS.
Okay, sir, thank you.
Alright. Yang ni memang kena clear dulu betul-betul. Yang ni kena clear betul-betul. I conjugate. So we have a I RMS equal to 0.4 angle positive. Tak tulis positif tak apa. Okay. Ampere. So bila conjugate, kita akan jadi negatif. Katakan yang ni negatif, so bila conjugate jadi positif. Dia conjugate ni macam mana? Yang berlawanan ya. Okay. So berapa jawapan dia? Bantu saya. Okay, kita buat step by step. Siapa yang belum buat, make sure kamu buat Okay, so the answer is 44. Okay. Angle 70 degree. Okay, angle 70 degree. The unit actually is volt ampere. This is, we call it a complex power. Okay, this is a complex power. Okay, complex power. Okay, dia punya simbol adalah S. Okay, complex power. Okay, tadi ada sahabat kita bagi tahu dia dapat angle 100. Bagi angle 100 bagi S ke? Okay.
Saya lupa conjugate degree dia.
Right. Lupa conjugate. Okay, good. Okay, so tengok lah yang tu kena conjugate. Okay, that's question number 1. Okay, question number 1. Okay, clear yang ni? Ada soalan?
Clear, sir.
Okay, good. So next question. Next question. Determine the apparent power. So how to determine apparent power? Apparent power actually is magnitude of S. Magnitude of complex power, which is equal to 44. Unit dia adalah volt ampere. Okay. Kalau apparent power, sorry saya tak tulis. This is apparent power. Unit dia adalah magnitude of complex power. Okay. So question number 2. Okay. Get to question number 2. Okay. Determine real power. So you have to imagine what is real power. The real power is P. And then reactive power is Q. Okay. Determine the real power and reactive power. Then draw the power triangle. Okay, that's the keyword. So first of all, we need to determine P and Q, real power and reactive power. Okay, real power and reactive power. That's okay. Okay, so what is a real power? So real power, we have our S. Now we have our S, complex power equal to 44 angle 70 degree VA, volt ampere. So this is in, this S actually is in polar form. So we can convert to rectangular form. Okay, rectangular form means we have information of real number and imaginary number. So how to convert? You can use your calculator to convert to rectangular form. Yang ni ada masalah tak untuk convert daripada polar form to rectangular form? Kalau ada masalah, tak tahu, bagi tahu saya. And then you have a 15.05. Saya buat slow-slow supaya tak ada yang tertinggal. Plus KJ 41.35. Unit dia masih lagi volt ampere. So from this info, from the complex number, complex power, we have information of P. What is a P? This is a P, which is P equal to 15.05. Betul? What? Okay, 15.05. This one, P. And then, okay, we have a Q. What is Q? Q imaginary part. Okay, positive Q, which is plus JQ. So Q is 41.35 volt ampere reactive. Okay, this is P and Q. So next question asks you to draw the power triangle. So how to draw the power triangle? We have a positive P. Sure, we have positive P. This is a P. Okay. And then we have a Q. We have a positive Q. This is important. Okay. Sorry tak ada pembaris. So saya guna ni mungkin tak berapa lurus. It should be straight line. Sorry. Should be straight line. Okay. And then this one is Q. And then this one is apparent power. Okay. So you have a Q 41.35 volt ampere reactive. And P equal to 15.05 watt. And then this is your S. S is 44. S is 44 VA. So this is the angle. The angle of power triangle, theta, equal to theta of complex power, which is equal to 70 degree. Yang ni penting. Yang ni sangat penting untuk kamu faham macam mana nak lukis dia punya power triangle. This one we call it a power triangle. Okay, ada soalan yang ni? Kalau ada soalan boleh terus tanya.
Saya error lah.
Ya? Arrow.
Kena lukis arrow ke?
Betul. Arrow kena lukis Arrow kena lukis.
Okay,
Okay, arrow kena lukis. Okay, arrow. Sorry saya punya lukisan ni mungkin tak berapa cantik ni. Okay. Alright. So next question number 3. 3 Okay, determine the power factor and load impedance. So power factor, commonly write PF, and load impedance, of course, ZL. Okay, look at to the circuit. What is the value of ZL? Okay, so how to determine ZL? Number one, how to determine? The question is power factor. Okay, what is power factor? Question number 3. Okay, question number 3.
Cos theta.
Okay, good. Power factor equal to cos theta, or cos the angle between V and I, the different angle between and I. In this case, we have angle, the different angle between V and I basically is equal to 70. So cos 70. Okay, guna je calculator kamu, cos 70. Okay, 0.34. Okay, the question is, our power factor is lagging or leading? Okay, so dalam kes ni kita tengok dia punya power Q. Q dia positif ke negatif? This Q. In this case, our Q is positive. Positive Q, so we have a inductive load. Okay, inductive load. So when we have an inductive load, so our power factor is lagging. Lagging power factor. Okay, lagging power factor for inductive load. Okay, or in other words, when we're talking about lagging power factor, so it means that our current lags voltage. Betul tak? Current lags voltage, look at the current. This is a current minus lags voltage, mengikuti voltage. Okay, bila kita draw dia punya phasor diagram. Kan, saya tak draw dalam kes ni. Hopefully you can imagine lah. Kalau nak draw pun boleh lah. You draw. Okay. In this case, lagging power factor. So the next question is determine what is Z. Okay, what is Z? Load impedance, ZL. Okay, how to determine ZL? ZL, you can determine for V and I. We know that V RMS divided by I RMS. Okay, divided by I RMS. Okay, this is a very straightforward. So V RMS 110 angle 85. Okay, divided by 0.4. Okay, 0.4 angle positive 15. Okay, angle 15. So from here you can determine Z. So what is Z? Okay, 275 angle 70. The unit of Z actually is ohms. Okay, positif kita dah tahu dia adalah inductive load. So bila kamu tukar kepada polar form, kamu akan dapat satu nombor yang akan jadi plus JQ, which is R plus JQ. Okay, positif. And positive, of course, we call it an inductive load. So inductive load, we have a lagging power factor. So the answer is this one. Okay, you can remain your answer in a polar form, or you can convert to rectangular form. Okay, rectangular form. Okay, ada soalan?
Tak ada, sir.
Okay, yang lain boleh follow Okay, kalau tak boleh follow, malu nak bagi tahu, boleh bagi tahu dekat chat ya. Okay, malu nak cakap, boleh bagi tahu dekat chat. Okay. Dan question number 1. Okay, dalam case ni dia bagi dalam bentuk rectangular form, tak ada masalah. Okay, you can give your answer in rectangular form or polar form. Okay, so next, look at the question number 4. Okay, question number 4. Okay, question number 4, a sinusoidal source supply, okay, 100 kVAR, okay, supply Q, okay, to the load. This is the load, okay, this is the load. So what you need to do first, you have to understand the circuit configuration. Okay, you have a source supply to the load with Q equal to 100 kVAR. Okay, so the question asks you to determine power factor. This is a power factor. What is power factor? Okay, number 2 asks you about the apparent power, S. Okay, the magnitude of complex power, and then Vrms. Okay, Vrms. Okay, so what you need to do, you need to draw the question number 4. So question number 4, okay, you draw the equivalent circuit based on the question, based on the information given, based on the given information. Okay, ZL, and then you have a ZL is the value of ZL. ZL is 250 ohms, angle minus 75 ohms. This is ZL, and then our load, okay, our source, we have a source here. Let's say we have a sinusoidal source here. So source supply to the load, supply Q equal to 100 kVAR, okay, to the load, supply to the load. Okay, so the question number 1, what is power factor? So how to determine the power factor? Question number 1, okay, how to determine power factor? What is power factor? Okay, so dalam case ni given Z. Okay, so power factor, we know that power factor equal to cos theta. Okay, cos theta, the different angle between V and I. Okay, dalam case ni the different angle between V and I sama juga cos theta, the angle of Z. Angle of Z kita dah discuss sebenarnya sebelum ni. So dalam case ni angle of Z is given. Angle of Z is given. Okay, angle of Z equal to minus 75. So our cos theta equal to cos minus 75. So the power factor equal to cos 75. Okay, cos
0.25.
0.26. Okay, good. Okay, lagging ke leading?
Ini lagging. Sebab dia inductor. Lagging.
Lagging ke? Tengok, dia punya angle dia positif ke negatif?
Negatif.
Negatif. So dia adalah capacitive capacitive load.
Sir, tapi kenapa dia letak ZL lah ke L2?
ZL refer to the load. Sorry.
Oh, okay.
No. ZL refer to the LOAD, load. Okay. Okay, capacitive. Angle negative, we know that capacitive. Okay, capacitive load. So leading power factor, leading power factor. Yang ni penting tau, penting. Sampailah kamu ke tahun 4 sebenarnya. Okay, clear. Okay, yang lain sepatutnya clear yang ni. Saya tak pasti saya terlalu slow ke terlalu laju. Kalau slow, tak apa kot. At least kamu boleh follow. Ini penting. Okay, power factor, leading power factor. Question number 1, power factor. And then look at the next question. Determine the apparent power. Okay, S, apparent power delivered to load. Okay, so what is apparent power? So apparent power is, okay, determine the apparent power. This is question number 2. Magnitude of S magnitude of S. Okay, given Q. Okay, yang ni macam mana nak cari? Tak perlu hafal formula sebenarnya. So you just draw the power triangle. Okay, dalam kes ni kita ada capacitive load, bermaksud dia punya Q adalah negatif. Betul? Okay, betul. Sepatutnya betul lah Capacitive load, this is a P, this is a Q. Q dia adalah negatif. Kalau kita draw dia punya power triangle, Q equal to minus 100 kVA R. And then P is not given. And then the question asks you to determine apparent power. So how to determine apparent power? You can determine the apparent power according to the power triangle. Power triangle. What is the angle? Okay, angle equal to 75. 75. Minus tu maksudnya kamu punya Q adalah negative Q. Okay? Okay, this one clear? Okay?
Clear.
Okay. So next, the question asks you to determine the apparent power. So how to determine apparent power? You can simply apply the concept of trigonometry. Okay, trigonometry. What is the relationship between S and Q? Okay, what is the relationship between S and Q? Okay. What is the relationship between S and Q? So, mostly dah tahu kan? So, sin theta equal to Q divided by S. Is it correct? Betul? Betul So, S equal to Q divided by sin theta. In this case, Q is given 100 K divided by sin theta is sin 75 degree. So your apparent power equal to 100K divided by sin theta. Sin theta is 75, which is equal to 103.53. 53 kilovolt ampere. Kilovolt ampere. Okay, betul lah. Okay, betul. Okay. So next question. Next question dia tanya berkenaan dengan question number 3. Tanya berkenaan dengan RMS voltage. What is RMS voltage? Okay, what is RMS voltage? What is the RMS of the source voltage? This one. Then VRMS. VRMS. What is the RMS voltage? Okay. Okay. Macam mana determine RMS voltage? Tolong buat, tolong jawab. Okay, what is RMS voltage? How to determine RMS voltage? Daripada mana kita determine RMS voltage? Sekarang ni kita ada info Q kita ada info cos theta dan kita ada info apparent power. So what is RMS voltage? Boleh? Dapat? Cuba kira RMS voltage. Dapat tak? Okay, alright. Macam mana determine VRMS? Okay. Apa info yang kita ada? Info yang kita ada sekarang ni adalah S, apparent power. Apparent power, we already calculate apparent power which is equal to 103.53 kVAR. And then we have a Z. Yeah, we have a Z which is 250 angle berapa Z ni? Minus 75 degree. Okay. Minus 70. Okay, minus 75 degree ohms. Okay, so apa relationship? What is the relationship between S and Z? Okay, we know that S equal to V times I, or V times I. Ini magnitude This is all. This one is actually is magnitude. V times I. The magnitude of V times by the magnitude of I. Dekat sangat saya tulis the magnitude of I. Or in other words, we can write V square divided by Z. V square divided by Z. Okay, we have a S, we have a Z, and then we need to determine V square. This is basically this one is actually is VRMS. Saya tak tulis tadi. This one adalah VRMS. So V equal to S magnitude times similarly to the Z, the magnitude of Z square root. Okay, square root, which is S 103.53 K. Saya tulis K darab dengan Z equal to the magnitude of Z actually is 250. Okay, then you square root. Okay, then you square root. So then you can get the answer equal to 5.087 kilovolt RMS. Kilovolt RMS. Simple je lah sebenarnya. Tapi okay, kadang-kadang kita start kita tak faham, lupa konsep dan sebagainya. Okay, so ada soalan ini untuk exercise chapter 5. Kalau ada soalan boleh tanya.